So in this video, we're going to talk about graphing linear inequalities. A linear inequality means it makes a line, so it has both an x and a y, and you can graph it basically. Before we get into this, I want to refresh what happens if you just have one variable rather than an x and a y. So remember in the last unit we talked about graphing things like x is greater than or equal to 2. Since this is only one variable, you would only need one number line for the x. It would be a closed dot at 2 since it could equal 2. So we would do a closed dot at 2. And then since it's things that are bigger than 2, we would kind of shade things that are bigger than 2, things that are to the right. If it hadn't had an equal to sign, if it had just been x is greater than 2, that's not a 2, then it would be an open circle because it didn't quite equal to, it was just right up close to it. So now that we're into linear inequalities, which something like y is greater than 2x plus 5 or something like that, this now has an x and a y. And so I'm going to need an x-axis and a y-axis because I have two variables. So it's going to be on the coordinate grid, basically. This is going to work pretty similar to how inequalities work, which is one variable. You're going to either do a solid line if it's greater than or equal to or less than or equal to, and you're going to do a dashed line if it's just greater than or less than. Basically, if you have a solid line, that's similar to doing like a closed dot, as in like it might equal the line, whereas a dashed line represents like it's going to get right up close to the line but not actually hit the line. It's not including the line. So like with a solid line, basically the line is included in the answers. Where with a dashed line, the line is not included. The line is not included. And then you need to know basically whether to shade above the line or below the line. Just like with this, you need to know whether to shade to the right or to the left. In this case, you're going to shade above if it's a greater than, and shade below if it's a less than, which makes sense. If we want stuff that's bigger than the line, we shade above it. If we want stuff that's less than the line, we'll shade below. This could also be greater than or equal to, or this could be less than or equal to. I'll show you another way you can figure out which way to shade in just a second. So your answer is not going to be just a line. Your answer is going to be like a line, and also like you're going to either shade above or below. And everything in this region represents answers to this inequality. So for example, I want to graph this inequality. So like, what two numbers added together are less than or equal to 3? Basically, a good place to start is to graph the line. And if I want to graph this line, I need to have y by itself. So I'm going to subtract x from both sides so that it's in like y by itself. And then I've got negative x plus that 3. Now, first of all, just pretend that this was just an equal sign, and I was just going to graph y equals negative x plus 3. So the y-intercept is 3, so I'll start here at 3. And the slope is negative 1. It's negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and so on. So before you start drawing your line, you may want to wait because it might be a dashed line. So in this case, it is less than or equal to the line. And so since it could equal the line, I'm going to do a solid line. If that little line wasn't there, I would have to do a dashed line. Also, this tells me that I want values that are less than the line, so I'm going to shade below. So everything in this entire region would make this true. But everything in this region over here would not make it true. So for example, like pick 0, 0. 0, 0 is supposed to work. If I do 0 plus 0, is that less than or equal to 3? Yeah. If I do something right on the line, that should even work because it's a solid line. Like if I do 2, 1, does 2 plus 1, is that less than or equal to 3? Yes, it's equal to 3. But pick something outside of there, like 2, 2 is just outside of it. 2 plus 2 is not less than or equal to 3, so it's not shaded. So if you're ever not sure which way to shade, like above or below kind of thing, you could always just pick a point, like pick 0, 0, plug it in, see if it works, and that will tell you whether to shade that way or not. So just to be clear, this is infinite solutions. Like all of these points to infinity are solutions to that inequality. On this one, it's already solved for y, so I don't have to do any of that work. To graph it, the y-intercept is just a 0 because there's nothing there. The slope is 1/2, so go up 1 over 2, up 1 over 2, and so on, or backwards. In this case, there is not a little line underneath. Basically, I want greater than the line. I don't want it to equal the line. So in this case, I'm going to do a dashed line, which tells me I want everything that goes right up to the line, but I'm not including the line. And which way do I shade? Well, this is a greater than, so I'm going to shade above. Shade above the line. Everything in this region solves that inequality. For example, 0, 1. 1/2 times 0 is 0. Is that true? Yes. Or like 2, 2. Is 2 greater than half of 2? Yes. But if you pick something on the line this time, it's not going to work. Like 0, 0. 0 is not greater than half of 0. They're equal, but it's not greater than. Or like, if you plugged in this, it wouldn't work. If you plugged in this, it wouldn't work. So that's my answer on that one.